Hello, my name is Margaret Cravar, and I'm from the SAS R&D division, the Compute Services division in SAS R&D here at SAS Institute. And my presentation today is going to be discussing the best practices for moving your existing SAS applications to the Microsoft Azure cloud. The information in this presentation has been based upon current customer experiences. We've helped quite a few customers move forward. We're in the process of helping customers understand what needs to move forward. And we've also been helping customers that have moved and having issues. All of the information that we've learned with these initial customers, we're putting here into this presentation, and we're hoping that these lessons learned can help you with your move to the MS Azure cloud. I want to start off by saying that the information I'm presenting today is based upon what's current today. But as you know, the cloud is always enhancing themselves. And in 6 months, the best practices being discussed today may no longer be relevant. So just wanted to give you a heads up that this is as of spring of 2021. One of the things that you need to pay the most attention to before you start moving into the cloud is to make sure you have an extremely good understanding of your SAS application that's currently in place on your premise, that you understand all the layers, all the components of the SAS. You understand the success criteria of your business users that are currently using the SAS applications. Many of the success criteria of the users, of course, when moving to the cloud, is the expectation that things will run faster in the cloud. And this may or may not be a correct expectation. So we just need to understand what needs to be a successful criteria when moving there. We also need for you to understand several things that also come into about with your SAS applications, your source data, the raw data that you'll be using for the applications, any third-party tools, any authentication, any relational databases that you may be using, your SAS clients that you'll be using, where will they be residing? There's also information about high availability, whether or not that needs to be put in place. And from a security point of view, does your data have to be encrypted? The more of this information you know in advance, the easier it's going to be to make sure that your first endeavor into the cloud will be successful. After you understand the different criteria of your SAS application and what is needed from a core memory, IO bandwidth, network bandwidth that's needed, we also need to make sure that we match all of that up with the different types of SAS 9 servers that you'll be using, or the different types of VIA servers that you'll be using, so that we can get the correct Azure instances for what you're doing. One of the first things for you to understand is, from a SAS 9 perspective, you have a mid-tier and metadata servers. You have a compute tier. If you're running SAS Grid, there are multiple compute tiers, and you'll also be required to put in a shared file system. For VIA, you have your CAS controller and workers. You also have your stateful and stateless services that are running the microservices, Postgres, RabbitMQ, and you have the SAS programming runtime node that's there. All of these will need to be separate instances within the MS Azure. We have a link here on the slide that talks about the different types of instances. And we're going to talk about what's important when you look at the instances. You really need to pay attention to all the information that is on the Azure website for instances, so that you get an understanding of the type of processors that are used for your instance. A common instance that customers use is the EDS v3 instance. It's a nice instance up there. It's been around a while, but one of the things that you're going to need to pay attention to is the fact that that instance family can be one of 3 types of Intel processors. It can be a Broadwell, it can be a Skylake, or it could be a Cascade Lake. And unfortunately, the Azure portal does not give you the ability to determine what processor type you want when you spin up that instance. So you have to, after the fact, go in and run an lscpu command to make sure that you understand what the processor type was selected for you when you spun the instance up. And if you're running and you have multiple CAS workers or multiple compute nodes from SAS, you need to make sure that all of those nodes, all of those Azure instances are running the same processor. This way, when you go to do your calculations, they'll all be using the same chipset from Intel and it'll run the task in the same amount of time. One other thing that we suggest when you go is that we strongly suggest that you go with the Azure Unified, in other words, premium support when running SAS up in Azure, so that if you have issues, you can contact MS Azure for help. One other thing that I've been told to remind people of, it's kind of second nature to me, but I want to make sure others are aware of that, is that when you go and look at the Azure website, they're going to have a column that says vCPUs, virtual CPUs. From a SAS perspective, those are hyper-threaded and not physical cores. SAS 9 in particular only runs on physical cores, so you'll need to take that vCPU number and divide it by 2 to be able to get the physical core so that you understand what instance it is. I keep alluding to this web page. So what I'm going to do here is pull it up, and I've got most of the information in here. You can scroll over more to the left to get the actual instance name and the number of vCPUs. But the next thing I want to talk about are the actual other information that's extremely important for you to look at. I've actually gone to the EDS, so Edward David Sam version 4 series. These are all Cascade Lake processors. I'm looking at the 64 vCPU instance type. I've put a little box around the information so you can see what I'm talking about. As you can see, it has 504 gigabytes of RAM. The next bit of information that's extremely important is to go down the column titled temp storage. That's how much temporary ephemeral storage is inside of your instance. So the ephemeral storage can be used for temporary space. So you have 2.4 terabytes of storage there. If you go over 2 more columns to the right, you're going to see that there's a 615,000/3872. The 3872 is the amount of megabytes per second that you can achieve on this internal SSD drive. And if I take that number and divide it by the 32 physical cores, it means I'll be able to get 121 megabytes per second per physical core, which is right in the range of what we ask for in general for you to have for SAS file systems. If this is the good size, 32 cores is enough, and for all of your users, and that the 2.4 terabytes of disk space is great, then this is a good instance for you to use. However, if you need more than 2.4 terabytes of disk space that's going to be local to this machine, then we're going to need to look at the 5th column from the left, the maximum uncached disk throughput, which will talk about the megabytes per second you can achieve when you attach premium storage to them or ultra storage to the machine. As you can see, that number is significantly less than what you're getting on the internal drive. It's 1200. If I take the 32 physical cores and divide the 1200 by 32, I'm only going to get 37.5 megabytes per second per physical core, and that's significantly less than the I/O throughput we need for a typical SAS file system. So we need to talk about what we would be able to do to overcome that. There's a feature within Azure called constrained cores that we can use. I'll talk about that a little bit more in the presentation. And then the last bit of information that I'm interested in is the last column, which talks about the network. And here you can see we have a 30 gigabit NIC card in here, which is plenty of network bandwidth for most SaaS applications. Again, I've gone with the largest instance that's available in this family, and because it gives us the best numbers. But there are the other instances as you go up. And of course, as you go to a different instance, there is a different cost. I'm used to going with the largest and most powerful one, so I have the most expensive one, of course. So we talked a little bit about storage. So if you're familiar with SaaS, you know there's two main types of storage file systems that we use. There's the permanent SaaS data storage. This is data that will persist between your SaaS sessions, that'll persist if you do a reboot of your Azure instance. It's where you would put your permanent SaaS data files at. It's very important to be able to get at this information and to be able to get the IO throughput you need there. Generally, you read from the permanent SaaS data files during your SaaS applications a couple of times, and then you write things out at the end. But it's not the most heavily used file system for SaaS applications. The most heavily used SaaS file system is the temporary SaaS data storage. From a SaaS 9 perspective, we refer to that as SaaS Work and SaaS Utaloc. And from a VIA perspective, it's referred to as CAS Disk Cache. It's where temporary files are written. It's where, and then again, reused throughout the applications when you have multiple steps. It needs to be very fast. It's one of the areas that my team helps make sure is the fastest IO throughput. In general, I recommend 150 megabytes per second per physical core. And this is why it's very important, because that's a general recommendation. We need to make sure that what you currently have on premise is how close it is to that. If you are currently, I've worked with customers to get this file system as fast as 250 megabytes per second per physical core, then we need to make sure we implement that on the instances as you move into Azure. The link here, so that's why it's very important for you to understand the IO throughput so that we can make sure we set things up correctly. The link here on the page talks about the various type of premium storage out there. There's the premium storage comes in different sizes and in different speed. So we need to make sure if you need premium storage that'll persist between boots of SaaS and boots of the machine, that you have it there. You may have to use premium storage if you need more space than what's available in the temporary storage column on the previous slide. One thing that we'll mention is we want you to make sure that all of your storage, all of your Azure instances, whether the instances are for SaaS or for your shared file system, are all in the same Azure proximity placement group. So in other words, they're all close to each other, so there will be no latency in moving data from point A to point B. And as I mentioned before, if you're going to the premium storage attached to your instance, there is a constraint as to how fast the megabytes per second are to that. So we may have to utilize constrained cores. So what that would mean on the instance type we were looking at before that had 64 virtual cores is I would constrain it down to 32 virtual cores, 18 physical, and be able to double the IO throughput to premium storage because I did that. And if that's the case, then and that meets your IO throughput needs, then we'll be fine with using that instance type for your storage. Earlier, I mentioned that if you were using SaaS Grid, a shared file system was required. There's several shared file systems up in Azure. There's DDN's Exascaler. It is the current enterprise version of the community edition of Lustre that's been in Azure for years. The Exascaler has added quite a few enterprise class features into the WAM Cloud. It's giving you more support. And also DDN is available to help you install and maintain the shared file system. Recently, SciComp, a company, has put an offering in the Azure Marketplace for IBM Spectrum Scale shared file system. This file system was formerly known as GPFS. SciComp will install the software for you and they will maintain it for you. So all you do is tell them the capacity you need and they'll spin it up and make it easy. Of course, you can always bring your own license of GPFS and install it up in Azure if you would like. But these two are offerings of shared file systems. There's also the offering from Microsoft of the Azure NetApp Files, referred to as ANF. These filers use the NFS, Network File System, protocol for the shared file system. This protocol is designed for you to write once and read often. So it's okay for you to use for your persistent SAS data, provided you're not doing lots of write to that permanent file system. It should never be used for your temporary SAS storage, your SAS work, your SAS utoloc, or your CAS disk cache. So it is available there. It also has, it does not scale out as well as the other two shared file systems. So if you need to attach more than, say, 48 cores to the shared file system, Azure NetApp might not be the one to look at there. So we've talked a little bit about the instance types and the storage. The next thing that comes into play when you move up there is we want to make sure when you set the instances up that you're setting them up to be able to get the most optimum performance possible. I'm going to mention yet again the Azure Proximity Placement Group so that all of your SAS components, all of the security, all of your data are together within the same area of the large Azure data center. We don't want you to be going a quarter of a mile, 2 kilometers to get your data. We want everything together. We want you to also avoid NMI lockups. This is a feature that happens with iSCSI and SCSI drivers with the RHEL 7 3.10 kernel. It can actually cause your CPU to lock up under a heavy I/O load. There's some things that need to be done to make sure that you avoid these. The paper at the bottom of this slide, the best practices paper in the SAS support communities, goes into details as to what all needs to be done so that you can avoid these lockups. We recommend strongly that you use the Azure Accelerated Networking, that you enable that so that you can get the fastest networking between your SAS components. And even though you're using the accelerated networking, we would like to see all of your SAS components, your SAS storage, your SAS, the relational databases that are going with SAS, and your shared file systems that'll be on instances themselves to be all within the same isolated VNet so that no other applications will be using your private networking there, the isolated VNet, to be able to degrade the movement of data. So that's very important as well. Azure, in working with Microsoft Azure, they have strongly recommended that you keep the MTU size to be the 1500 default and you not change that at all. Again, all of the information on how to do these tunings, how to validate that the tunings are set the way you would like for them to, and all of that are in this best practices paper, which is out on the SAS Communities Administration site. And as we learn more information, we're updating this paper out there on that site. So what all does this mean? How would I get asked a lot of times, do you have a sample Azure instance that you would use? So I'm going to go back to the E64 that we talked about earlier on the instance page. I've constrained it down to 32 virtual cores, or in other words, 16 physical cores. I'm using the V4 family so that I can be guaranteed that everything I spin up is a Cascade Lake processor. We have the 504 gig of RAM, the 2.4 terabytes of internal SSD drive for ephemeral storage, maximum throughput over to the premium storage, because I want to have some locally attached storage for SAS data files to be placed. And the networking is that. It's the 30 gigabits per second. I also need to have premium storage attached for the persistent data. And since I have 1200 megabytes per second IO throughput, and I need a little over 5 terabytes there, I'm going to use the P30 drives. Each P30 drive is a terabyte in size and can give me 200 megabytes per second. So if I put 6 of those together, I get the 1200 megabytes per second that I'm allowed to put into the instance, and I get 6 of them, so I have 6 terabytes of space. So that meets my capacity for disk space. So this is a sample Azure instance. I'm sure a lot of you are going to sit here and say, that's a very large instance and maybe more than I need. But again, I need to have other criteria that I need to meet, which is IO throughput and physical capacity of disk space. So in conclusion, one of the things we need to understand is the workload and the expected SLAs of the workload, so that you're able to put together an instance type that is large enough and can meet the needs of your SaaS application, but may not be too large so that you're wasting money out there. But unfortunately, in order to meet IO throughput needs, it is quite possible that you are going to have to over-provision your instance with the number of physical cores along with the physical capacity of your storage so that you can meet the IO throughput SLAs. The number one reason why customers are unhappy with performance is that they have not put in place enough IO throughput, enough IO bandwidth to be able to have the processing of the large volumes of data that they're processing with SAS in the time frame that they would like to see them processed in. There's always a cost versus performance choice when you go up into the Azure cloud or any public cloud, that you need to understand what you would like to be able to get done and then the cost. So if you have a budgetary restriction, you may have to go back and reset the SLA expectations of your users, that, in order to get what they want, we don't have the budget for that. So you need to figure out a compromise between which way to go there to be able to meet the SLAs. That's always a big choice to do. But the one thing that's nice, and I'll let you know that, is the instance types, storage types are always changing in the public cloud. Just wait a few months and you'll be able to have a new instance type that's probably going to be cheaper and can give you better capacity and better throughput. One last thing I'd like to say in conclusion, I've alluded to this before, is the SaaS communities, especially the administration and deployment community. We're out there talking all the time about how to administer SaaS, not only on premise, but also in the public cloud, so that you'll be able to get the best information as quickly as we learn it. We will be blogging it out to that community. So we hope you all will join the community and be able to be part of that. I know I've gone through a lot of information very quickly, but if you have any questions, please let me know.